This is SpaceTime Series 29, Episode 87, for broadcast on the 22nd of July, 2026. Coming up on SpaceTime, ancient impacts displaying the red planet's past history, understanding the moon's regolith in preparation for future human missions to the lunar surface. And we check out the strange goings-on Pluto's binary partner Charon out in the Kuiper Belt. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
A new study has shown how ancient Martian rocks exposed on the rim of Jezero Crater are preserving a 3.9 billion-year-old weather report from the solar system's most dynamic era. NASA's Mars Perseverance rover has uncovered evidence that a 75-metre thick stack of debris around the Jezero Crater rim, known as the Broom Point Member, was built up by repeated asteroid impacts. The sequence of layered bedrock is likely more than 3.9 billion years old, making it among the oldest terrain ever examined on the red planet. The findings, reported in the Journal of Geophysical Research Planets, offers a new window into one of the most tumultuous chapters in the history of the solar system. Mars Perseverance rover project scientist Ian Farley from NASA's Jet Propulsion Laboratory in Pasadena, California, says that since leaving the crater, Perseverance has been exploring a chapter of Martian time that predates the crater itself. Planet Earth's earliest geological history has been fundamentally broken up, deformed and erased, partly thanks to plate tectonics. But because Mars lacks plate tectonics to recycle its crust, this ancient record remains intact, giving scientists a rare opportunity to glimpse a geological time period that doesn't exist on Earth. After ascending the western rim of Jezero Crater in early 2025, Perseverance began examining Broom Point. The data has revealed 6 distinct rock types, including breccias, that is, rocks built up from angular fragments, alternating with layers of fine-grained pulverized rock dust. The rock fragments within the breccias are pocked with glass bubble cavities, indicating they were once molten. The presence of tiny dark glassy beads within these layers offers an important clue about how the rocks were formed. See, while volcanoes can produce similar glassy droplets, they rarely occur in such high abundance. That points to an asteroid impact instead. In fact, the largest of these beads rivals those flung out by the dinosaur-killing Chicxulub asteroid impact on Earth 66 million years ago. Because these distinct rock types repeat multiple times throughout the thick sequence of rock, it indicates that high-energy impact events happened again and again across this region of early Mars. The different rock layers provide a record of different impact sizes and different distances from the Jezero Crater rim. Several of the layers look like they may have been formed by fast ground-hugging debris flows. On Earth, these powerful fluid-like surges can occur when molten rock hits water or ice that instantly flashes into steam. Some of Broom Point's layers tilt at angles exceeding 80 degrees, nearly vertical, and that's far too steep because by the impact they created Jezero Crater itself. Instead, scientists suspect a cosmic 1-2 punch shaped this landscape long ago. First, a colossal asteroid impact created the 1,900-kilometre-wide Odysseus Basin, one of the largest impact basins on Mars, upending and tilting the once flat rock layers. Later, a second asteroid hit, likely forming the 45-kilometre-wide Jezero Crater, where Perseverance landed. This second impact fractured and uplifted the already tilted rocks into the dramatic formations which the rover sees today. To pin down exactly when these events took place, Perseverance mission managers collected 2 core samples, dubbed Bell Island and Main River. Now, if a future sample return mission to Mars takes place, those samples could be brought back to Earth for dating in order to determine when and how often impacts were striking early Mars, and then by extension, how those impacts would have affected the early Earth, where the early impact record's been erased thanks to billions of years of plate tectonics and wind and water erosion. These are just the latest finding by the car-sized 6-wheel Perseverance rover since it arrived on the red planet back in February 2021. This report from NASA TV.
Mars is the closest place that we can reach with robotic exploration that we think had a really good chance of having ancient life.
Jezero Crater is a very interesting place. It's a crater that once held a lake.
There are a lot of craters on the surface of Mars that could have once hosted ancient lakes, but not every crater that we think had a lake actually preserves evidence that that lake was there.
It had an inflow channel and it had an outflow channel. That means it was filled, the crater was filled with water.
In Jezero, we have probably one of the most beautifully preserved delta deposits on Mars in that crater.
This is a wonderful place to live for microorganisms, and it is also a wonderful place for those microorganisms to be preserved so that we can find them now so many billions of years later.
There is no other place on Mars that has the unique combination of a lake setting, a beautifully preserved delta, and the diverse mineralogy that we have in Jezero Crater. So it's truly a special landing site.
The major goal of the Perseverance mission is to investigate astrobiology on Mars, and in particular, to address the question of whether life ever existed on Mars. The Perseverance rover starts with a design that's very similar to Curiosity, but we've added to it a whole new set of science instruments. And these science instruments were purposefully selected to help us in the search for biosignatures.
Perseverance carries with her a grand experiment in spacefaring technology, a helicopter, Ingenuity.
One of the major upgrades that Perseverance has from Curiosity is that it's able to self-drive for a distance of up to 200 meters per day. As the rover is driving, it's literally building the map of the road it's driving on Mars.
Scientists for years have told us that to really unlock the secrets of Mars, we have to bring samples from Mars back to Earth.
Drill samples, put them in small tubes. We set them on the surface to provide a target for the second two missions, which hopefully will get in development in the next several years and could potentially get the samples back to Earth by 2031.
Perseverance is a very, very profound first step in both our understanding of our place in the universe and a stepping stone towards human exploration on Mars.
And in that report from NASA TV, we heard from Mars Perseverance rover Deputy Project Scientist Katie Stack-Morgan from NASA JPL, Mars Perseverance rover Project Scientist Ken Farley, also from NASA JPL, Mars Perseverance rover Deputy Project Manager Matt Wallace, another JPL representative, Mars Perseverance rover Chief Engineer Adam Stelzner, also from JPL, and another JPL scientist, Mars Perseverance rover Mobility Team member Farah Alabay. This is Space Time. Still to come, understanding the Moon's regolith in preparation for future human missions to the lunar surface. And we check out the strange goings-on Pluto's binary partner Charon out in the Kuiper Belt. All that and more still to come on Space Time. Scientists have mapped out the thickness of the Moon's regolith, a layer of loose dust and rock that covers the entire lunar surface, finding it averages around 6 meters in the highlands and around 4 meters on the Maria. The data, reported in the Planetary Science Journal, are based on the analysis of more than 300 small and freshly formed impact craters across the lunar surface, together with data collected from lunar missions dating all the way back to the 1970s Apollo era. The study's lead author, Andrea Razik from Brown University, says understanding the lunar surface is important for future manned missions to the Moon. Our Moon is under constant bombardment from meteorites and other impactors, which are the main drivers creating the lunar regolith layer. The authors looked at 346 relatively fresh lunar craters, examining the blanket of debris surrounding each crater. Impacts that penetrate through the regolith layer to reach bedrock eject massive boulders onto the surface, which are clearly visible in satellite images. Once Razik and colleagues determined which craters exposed bedrock and which did not, they used known relationships between crater diameter and depth to estimate regolith thickness regionally right across the lunar surface. And the findings resulted in revealing patterns in lunar regolith thickness. The lunar highlands were found to average around 6 meters deep, while the lowlands, where the Maria are, were thinner, around 4 meters. That matches previous hypotheses. Scientists have long thought that regolith is likely to be thicker in more ancient terrains, such as the lunar highlands, compared to the Maria, the large volcanic plains visible as the dark patches on the lunar near side. Depending on the objectives of a given Artemis mission, landing where there's more or less regolith could be an important factor in mission planning. Razik says in a situation where you want to build a lunar base, thinner regolith could make it easier to reach more competent material for foundations, depending on the construction method. On the other hand, if you're thinking about resource utilization, there may be a lot of useful things trapped in the regolith, like water ice and helium-3. This is SpaceTime. Still to come. A new study finds the rotation of Pluto's binary partner Charon is slowing down. And later in the science report, a new study has revealed that heart disease can be linked to 9 specific molecules produced by your gut biota. All that and more still to come on SpaceTime. A new study has found that the rotation of Pluto's binary partner Charon is slowing down. The findings, reported in the journal Nature Communications, are based on new computer simulations of this distant Kuiper Belt world beyond Neptune. The study's authors say Charon spins around every 153.3 hours. That's much slower than its original spin cycle of around 14.3 hours, suggesting a gradual slowing down or de-spinning of its rotation. The authors say celestial bodies across the solar system are thought to undergo some degree of de-spinning, in which tidal forces slow their rotational rate, altering their shape and temperature. Although this same process had long been theorized to occur on Charon, clear evidence has been lacking. But Charon is a promising candidate for such evidence, as its 4 billion-year-old surface has experienced relatively limited resurfacing compared to other icy bodies. The new findings are based on a detailed study of variations in the orientations and types of tectonic features of mountain ranges in the Oz-Terra region of Charon's northern hemisphere. These features extend over more than 200 kilometres and show asymmetric slopes consistent with compression rather than extension. The study's computer simulations suggest a 30 to 36 kilometre thick ice shell cloaked Charon when it was formed, and that the crust near the equator is shrunk by about 1%, with the compression absorbed along existing fault lines and creating ridges as the frozen world aged. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with a science report. A new study warns that having heart disease could be linked to 9 specific molecules that are produced by your gut biota. A report in the journal PLOS Medicine analysed the blood of several thousand people and found several gut micrometabolites, that is, compounds created by your intestinal biota, that were associated with the risk of developing coronary heart disease. The authors then used that data to validate and refine the link, accounting for other factors that could be associated to heart disease, such as age, family health history, and diet. They say the 9 gut microbiota found in the blood could be used to determine whether a patient has a higher or lower chance of developing heart issues, and it could be a promising avenue for the development of new treatments to help prevent coronary heart disease. A new study has found that more than 1 billion people around the world now face at least one day of extreme heat stress every year compared with the 1970s. The findings, reported in the journal Nature Climate Change, analysed a global data set of human heat stress from 1950 to 2024 and found that feels-like temperatures have risen on the warmest days and nights since the 1970s, with nights warming up faster than days. The authors say extreme feels-like temperatures are now more frequent on every continent, and exposure to at least one day of extreme heat stress has risen from 16 to 22% of the global population. That's around 1 billion people. A new study claims consuming an avocado every day lowers the risk of heart disease in people with obesity. The findings, reported in the Journal of Clinical Lipidology, are based on a 6-month study. The authors found that people with obesity who ate an avocado every day reduced their blood levels of low-density lipoprotein particles, which transport low-density lipoproteins, the so-called bad cholesterol. The authors found that regular avocado consumption was associated with an approximate 4% reduction in heart disease risk. The risk posed by low-density lipoprotein particles is typically higher in people with abdominal obesity. Mind you, it's worth pointing out that this study was supported by the Avocado Nutrition Center. A new study has shown that just like people, monkeys appear to dislike artificial intelligence avatars that look like them, but are just a little bit wrong, an effect known as the uncanny valley. A report in the journal PLOS Biology claims that at first monkeys responded to AI monkey avatars just as they would to footage of real monkeys, suggesting that they thought the animated monkeys were real. However, when they progressively tweaked the animation to look less and less realistic, they found the monkeys paid less attention to those with only slight changes compared to either the truly realistic ones or the more unrealistic versions. The authors say this shows that monkeys, similar to people, show an uncanny valley where almost realistic stimuli are liked less than ones that are highly realistic or very unrealistic. Apple have just released the public beta version of their new iOS 27 operating system ahead of its September launch. With the details, we're joined by technology editor Alex Zaharov-Reutt from TechAdvice.live, who's been testing the program.
Apple has launched the public beta versions of its operating system for the iPhone, the iPad, the Mac, the Watch, Apple TV, and the big feature is Siri AI. The rest of it is more or less a cleanup of the previous iOS 26. They've managed to make it more efficient, make apps load faster. Now the image generator can generate photorealistic images. Before there were sort of three cartoony styles, and it sort of almost felt for a lot of people that iOS 26 was one big long beta program, and that iOS 27 is the one that fixes the bugs, cleans it up, makes things nice and fast. I've been running the developer beta on an older iPhone, but as of the time that the beta was available for the public, I backed up my photos on my phone. I already have the rest of it backed up to iCloud, and I downloaded the update. It was, I think, 30 gigabytes or something. It was quite large. Took a while to download, but I've got a pretty fast connection at home. And, you know, I put it on and more or less I've forgotten that I have a beta on there. I've noticed the battery going flat a little bit faster on my phone and watch. But the big thing that you notice straight away is Siri AI. Now, you need to have an iPhone 15 Pro, 16 Pro or 17 Pro to be able to use the latest features of Siri AI. If you have an older iPhone, it will just appear to be like last year's version of Siri. You should still get access to the Siri model that gives you world information and better results. But with the newest iPhones, you can actually also now have a much more natural human-sounding voice, and you can customize it, its pitch and its tone and expressiveness. But again, that's only on the latest devices. But you can now have a Siri AI app, which is like the ChatGPT app or the Claude app, ask all sorts of questions, have a record of what it is you've spoken about, and be able to go backwards and forwards and get intelligent answers from Siri AI, just like you would expect to get from Gemini, ChatGPT or Claude. And the ability for the phone to actually understand what you're asking it to do, and then to be able to get the phone to do things, whether it's set appointments or look for information from SMS messages or emails or documents that you've saved about what the password is for a place you're staying at, or what the code is for a lock that you've got, or who it is that you met a few weeks ago at a certain cafe. That information is now going to be much more easily able to be surfaced because Apple has improved the search and indexing on your phone. And in fact, one of the complaints when you put the new beta version on is that it can take a while, a day or two, for it to fully index all the information on your phone. But the whole idea is that that information is not shared to the internet and to other people. No one's using your information to train the model, so you get Apple's privacy, but you also get a much more satisfying experience of being able to find things, whether you're doing a quick search or you're doing a more deeper search. And so look, the first beta is out. I haven't really noticed any show-stopping bugs of any sort. I've forgotten that it's there, but it just feels snappier and faster, and Siri is actually now worth a damn.
That's Alex Zaharov-Reutt from TechAdvice.live. And this is Space Time. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Bytes.com, SoundCloud, YouTube, your favourite podcast download provider, and from spacetimewithstuartgary.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to spacetimewithstuartgary.com for full details.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.